Electricity has standard numerical values that you need to understand if you want to work in the electrical field. The ampere or amp is a measure of the actual amount of electricity flowing in a circuit.
The ampere is a rate of flow. It's similar to measuring the amount of liquid that flows through a pipe. Two factors must be considered when measuring flow: quantity and time. There's a big difference between a flow rate of 1 gallon per minute and 1 gallon per second.
Voltage itself does not flow through the circuit. Voltage is the force that pushes the electrons through the circuit. It's the electrons that flow, not the voltage. A good analogy for voltage is to think of water flowing through a pipe. Voltage is like the water pressure, and the electrons being pushed through the circuit are like the flowing water. In fact, voltage is often called electrical pressure or potential difference.
A standard receptacle outlet contains voltage or potential between the two main conductors, but there is no current flow until the circuit is completed by connecting a device that allows current to flow.
The ohm is the unit of resistance to current flow. Resistance hinders the flow of electrons through the circuit. A good analogy would be the resistance you feel when you're in a pool or the ocean up to your chest in water and you're trying to walk. Electrical resistance is much the same way. The greater the resistance, the greater the hindrance to the flow of current.
A resistor in an electric circuit can be compared to a restriction in a water system. The reducer limits the flow of water through the system, just as a resistor limits the flow of current through an electrical circuit. Wattage is a measure of the amount of power that is being used or consumed by the circuit. Electricity is a form of pure energy. Energy cannot be created or destroyed, but its form can be changed. Watts is a measure of the amount of electrical energy that is being converted into some other form. An electric range converts electrical energy into thermal energy. An electric motor converts electrical energy into kinetic energy. The amount of energy supplied to a device is proportional to the flow rate and the pressure. For instance, the amount of turning force produced by a turbine is proportional to the amount of water supplied to the turbine blades and the pressure of the water. Electric power is basically the same. The amount of watts or power is proportional to the amount of current flow or amps and the pressure, voltage, being used to push the electrons through the circuit. If the lamp is replaced with another lamp that offers less resistance to the flow of electrons, the flow rate will increase, causing more electrical energy to be converted into more light and heat. Another common measurement of energy is the BTU, or British Thermal Unit. 1 BTU is the amount of heat necessary to raise 1 pound of water 1 degree Fahrenheit. The BTU is often used to measure the cooling capacity of air conditioning equipment, or the heating capacity of a heating system. 1 watt is equal to 3.412 BTUs per hour.